Hello everyone, and welcome to today's webinar, Smarter Insights from Smarter Cameras. We are going to give it 1 minute more or so to wait for people who are joining and still might need to finish up their registration procedure to get in. In the meantime, we can start with sharing a poll to see how familiar you are with Axis cameras so that I know what type of audience I am talking to. So you should now see a poll on your screen where you can answer the option that feels most familiar for you. You see now that we start getting a few different answers getting in. It's really nice to see that we have a quite good spread of people. Everything from on the more novice level to advanced people actually already developing ACAP applications. So that's very interesting to see. And with that said, let's continue with the actual webinar. So what we're going to talk about today is how to create better dashboards with more insights. And the key here that we will focus on is not on the actual design of the dashboards itself. It's more on how to know what you should show in the dashboards, and especially how can you be able to collect this information, to gather this information or generate this information based on what is happening in the physical world. So the first thing that you should ask before you start doing this is, who is your operator? And the reason you should ask this is that the ultimate goal of creating a dashboard is to create insight for someone. And if you don't know who the person is that you're going to create insight for, it's also very hard to know how to create insight for this operator. So in some cases, there might not even be any operator in the sense that anyone is watching the dashboard. It might be that the dashboard is only there to be reviewed once per month, for example, to look at historical data, or it might be that the dashboard is only used if an incident happens. And in that case, it might be good to have alarms or notifications on your dashboard. So if something actually looks strange, then someone gets notified about, now you should look at this dashboard because something strange, unusual is going on. And then it's also very important to know what is the procedure for acting on this alarm or this notification. Some companies in some situations have very long list of procedures that you need to go through as soon as there is alarm to make sure that you have actually looked into all the things around it. While in some cases, the procedure might just be to take a quick look at the dashboard, see that, looks kind of fine, and then forget about that. And these two different extremes, of course, put a lot of different requirements on the accuracy that is needed for your alarms. And another thing might be that if you have a push notification, for example, and have some kind of preview in that push notification, then maybe the operator don't even need to open the dashboard to look at it if it's a false positive. So there's a lot of things you can do to reduce the pain of false positives. And I said, is it a live dashboard or is it a historical dashboard? Is someone looking to see what happened during the last month, or is it a dashboard that is constantly live and showing what is happening right now? And this, of course, put a lot of requirement on your data pipeline. If you have a real-time dashboard, there's a lot of factors affecting the latency of the system. How long time does it take from the event happens in reality to that it is visible on the dashboard? And that is typically not something that you need to care much about if you have a historical dashboard showing the data from the last month, for example. And finally, what is the ultimate goal of the dashboard? Before you create the dashboard, you need to know what what things can change in a positive way if I create this dashboard. What is the ultimate goal that the one ordering this dashboard want to get to? So we can see the dashboard as kind of like a puzzle. Each data piece or each information is one single piece of insight. And one piece of insight or one piece of data or a single metric typically doesn't mean very much. But when you combine these over time and with context, then it becomes insight, and that is really what we want to achieve. So for example, if we consider the audio signal on the right, we can see that we have a spike, something loud occurred at a specific timestamp. This alone doesn't tell us much about what happened, but with more context, we can get more insight about what was actually going on. So for example, if this happens at a reception desk, then perhaps the image can show us that this is some aggressive person that is screaming at the one behind the counter. And the task to do in this case might be to notify the security staff to go and handle the situation. While the same very similar audio could be someone screaming because they are falling in the staircase. And in this case, it might be enough to look at the video, see that the person raised up again and walked away on his or her own. And then they might not need any further action. So it's all about context, combining different kind of information with each other. So a sensor doesn't produce insight. A sensor provides data that we can combine with context over time to create insight. And that is what we need to remember. So we need to always start with what insight do we want from our dashboard, and then we go backwards from that and look at what sensors do we need and what information do we need from our sensors. So this essentially means that you should design a sensor that gives you the data you need for the insight that you want to get to, not the other way around, that you start with, we have these sensors, this is what it can produce, and then think about what dashboards can we create with this, because then you would probably end up with a cool looking dashboard, but that doesn't produce much value for people. Another concept to know is that dashboards span silos. As I said, you typically need to combine data from different sources, and sometimes these different sources are totally different silos. In one case, we can, for example, consider looking at a door that should be closed when it's not utilized. If you just measure the state of the door, is it open or is it closed? Then that doesn't tell you anything at all. That value isn't worth anything. If you just measure the footfall through the door, again, it doesn't tell you anything about if the door is open or closed. So it's not valuable for you. But if you combine these two, then you can see, is the door open when no people are walking through it? Then we should trigger an alert to notify someone to go and close the door. So these are two measures that are relatively similar from the same kind of domain, but we can look at different things. So for example, comparing sales numbers in a POS system to the queue length in the store. So one metric is a physical metric that we need to observe using cameras, for example, in the store, while the other one is digital data from your point of sale system. So it's two completely different silos that you need to combine to create this valuable dashboard statistics. And another one is, for example, temperature versus room utilization. A room might be allowed to have a higher temperature if people are using it, but if people are not using it, maybe we want to reduce the temperature in the room to save on electricity for heating. And we also need to consider that the same data can be visualized in very different ways depending on what the goal with the dashboard is. So we might, for example, use the same sensors to produce both an operational efficiency dashboard and a business intelligence dashboard. So on the left side here, we can consider a door again that should be closed when not in use. and we can visualize the footfall through the door, and we can visualize if the door is open or closed. And this would be a real-time dashboard that updates as quickly as possible, and gives us the historical view over the day, for example. So this dashboard might be useful for a shift supervisor, which is currently working in the warehouse, and who is looking at this to see, are we handling this as good as we should. But then at a more business level, we might have this business intelligence dashboard on the right, which is more for the leadership in the company to look at. So here we might have a historical view over the month or even the year or maybe the quarter. And we can visualize things such as the heating cost for the warehouse. And again, this is from a totally different silo, but you can still combine it in the same dashboard to create more value by combining things that make sense together. And then we might take these two metrics that we have on the left side and use them to calculate a door efficiency metric over a month. So what percentage of the time that the door was open was there actually someone walking through it? So it's two completely different dashboards for completely different persons, but they are using the same information, apart from that the right one is also fetching data from another data silo. So with this mindset that you should start with the insight and then create your sensors from that, we usually say that you deserve better than one size fits all. There are a few different sensors that are available, and what a lot of people do is they look at what sensors are available, what information can we collect using these sensors, and then they build their dashboards based on that. But if you start the other way around and say that I need this information for my dashboard, then you can create a sensor using computer vision and cameras that measures exactly what you need in exactly the kind of way that makes sense for that metric. And this is what you can do with ACAP applications, edge applications running directly in the Axis cameras. So they are essentially converting your video security camera into an intelligent sensor that outputs metadata about what is happening in front of it, for example, one specific metric that you want to track. And when we started FixIt, we were focused on how to make ACAP application development more easier and quicker. And we usually say that we took down the development time for one application from about 200 days to 20 days instead, by introducing our tools and frameworks and processes for efficiently building ACAP applications. And while doing this, we also reduced the number of bugs and increased the robustness of the application, and also reduced the maintenance cost of the application. The next step we did after that was to ask the question, what would it take to cut these 20 days into 2 days instead? And what we ended up with then was an ACAP application that we are selling now called the FixIt Data Agent. And this is essentially an data processing agent that runs directly in the camera and can make use of interpreted script files, so both shell scripts and a Python-like language called Starlark. And this operates on the metadata level, meaning that you typically won't use it with raw pixel values or raw audio data, for example. Instead, you're using it together with other modular applications that are outputting some specific information. So we have, for example, our QR code decoder that can detect QR codes and output information about where they are in the screen, how big are they, what coordinates, what rotation, what data do they contain, and so forth. And this is then sent to the data agent as a metric, a JSON document essentially for each detection. And the same we can do with the built-in object detections in the camera from Axis Object Analytics. We can make use of people detection, vehicle detection, so forth, and get the coordinates and size of those detections. And then we can process that in the data agent. So with this model of thinking and interpretable modern languages and a large set of ready-to-use plugins, we could essentially cut down the development time for one use case to these 2 days that were our goal. So the three things that the fixed data agent excels at is monitoring device health. So this is the built-in functionality that it does out of the box when you install it. It collects a lot of system health metrics from your camera, such as CPU, memory utilization, flash usage, what Access OS is running, different processes, how much memory each process is consuming, and so forth. And a lot of network statistics also. So with this, you can monitor what is the health of the device. The second thing you can do is what we are focusing on in this webinar, is that you can use it to build custom dashboards. So we already have an open stack for creating dashboards with data that are sent from the fixed data agent, which means that you can easily extend the data agent to collect more data or calculate more data from the device and populate that in your dashboard. And the last thing you can do with it is analysis and automation directly on the edge device. So looking more on the data sources, built into the Access cameras are object detection and object tracking. So you have object detection such as face detection, human detection, license plate detection, vehicle detection. These are different kinds of objects that the camera can detect where are they, and they can track it over the time to give you essentially a track where each object have been visible. And then there are different use cases that you can implement in the Access camera using Access Object Analytics, such as object in area alarms, line crossing events, occupancy in area measurements, for example. And these are use cases that builds on top of this low-level object detection and tracking data. And what you can do with the fixed data agent is that if none of these use cases are good enough for what you need to do, then you can hook in directly to the object detections and tracking information from the camera, and you build your own use cases using this Python-like language in the data agent. And you even get more information than that. For people, for example, you get upper and lower body color, and you can get information about if they are wearing hard hat and personal protective equipment. There is nowadays even re-identification information built into the object tracking, which makes it even more powerful for use in the data agent. And if you make use of a fusion camera that also have a radar, then you can get very exact speed for vehicles, for example, that is connected to this object detection in the visual from the visual image. So there's a lot of information here that you can use for a lot of use cases that isn't built into the camera out of the box. So it might, for example, be looking at people waiting at a bus stop. You can analyze how they are moving directly in the fixed data agent to differentiate people just walking by the bus stop from people actually waiting at the bus stop. You can differentiate between people turning left or people turning right in an intersection. Or in a roundabout, for example. And you can do more advanced things such as looking at people entering or exiting vehicles. So all this can be done with just object detections that are already in the camera. So let's, for example, consider one use case for retail, which is about group counting. And what we need to consider here is that group counting isn't one single thing. There's a lot of different scenarios and use cases where you might want to do group counting. And a group is essentially a social construct. There's no strict definition for what constitutes a group. If you are in retail, then you probably want to look at shopping units, how many families or how many groups are working around in the store. Because they typically buy things together. So it might be more interesting to look at that than to look at individual people. But if you're looking at a train station, for example, at people waiting at a train, then groups might be something totally different. And since there's not one single definition of it, that also means that there's not one algorithm that is called group counting. There are countless different algorithms that can do group counting, and they do it in different ways using different assumptions, and they make sense in different use cases. So this is again why you shouldn't accept one size fit all, because then group counting will be something generic that might not fit very well to the type of information that makes sense in your dashboards to create real insights. So instead, with the data agent, since it's so easy to implement new use cases, you can go in with this exact definition. What do I mean with a group and what is important for this use case? And then you create the algorithms to actually make sense for that. So let's take a look at what this enables. When you implement these kind of applications, what kind of dashboards can you build with it? So I'm going to show a few different examples of things that we have done for dashboards. And as I said before, dashboards spans silos. So in many cases, what I show here will not be a complete dashboard. It will be more an element in a dashboard. And you might need to combine that to external data, such as point of sale information, to make it really valuable. So the first use case we're going to look at is hero product performance analytics. So according to a study published by the Journal of Marketing, a well-designed display can increase sales by up to an astonishing 540% when compared to unorganized or cluttered displays. So this means that there's a significant upside to your sales numbers in a brick and mortar retail store if you can figure out how to best structure your product displays that are close to the entrance of the store. So the insight that we want to gain from this is the answer to the question, how good is my current display? And this allows you to do these iterations and compare different versions to see what works better and what works worse. So one way you can do this is to use our time in area analytics configuration, which can give you the total duration for a track in a zone. And then you can put up two different cameras looking at the two different hero products or power walls that you might have. And you track how long time does each bypasser spend at this site. So if you have very low numbers here, it means that they are just walking straight past it. But if you have a display that is attracting people, then they probably spend more time there. So it gives you this kind of information that is valuable for optimization. And in this case, what we have done is that we created both a floor plan of the site and we visualize the live numbers directly on that floor plan. And we also do the historical data on the right side. So here we see a histogram. So all the number on the y-axis is the number of people that have walking by, and we can see this particular bypass or how long time did they spend in the zone. So if you have numbers or bars further to the right, then it means that they are staying longer at the hero product. And this was implemented with our fixed data agent running our time in area project. So you can scan the QR code and find more information about that time and area application. But it's very similar to Access Object Analytics time and area, with a difference from that it outputs more metric data that allows you to do these visualizations, and it also works on the Access fisheye cameras. And the whole time and area application is also open source, so you can easily adapt it and extend it to fit your needs. Going to the next use case, which is live building status, creating a digital twin of your facilities. So retailers that implement digital twins report high operational efficiency and lower costs. And this is enabled by more efficient space utilization, optimized store layouts, and energy savings. So the insight that we want to answer with this dashboard is, how efficiently do I use my spaces? So very similar here, we have added image, in this case an isometric 3D view of our office as the background in our dashboard. And we have created these live overlays directly on this image. So to the left, we see the occupancy, and we see some footfall related statistics, like what is the occupancy over time and what is the occupancy overall days laid on top of the time of the day, so we can see what time of day is more busy. And on the right side here, we have also added a door state indicator, so we can see the live status of our door. Is it open or is it closed? And we can see on the timeline also if the door is open or closed. And this was again built with a fixed data agent, but in this case, for occupancy, we are making use of Axis Object Analytics to extract the occupancy number. And for the door open or closed, what we did was to put a small QR code in the corner of the door, and we let our existing camera detect is that QR code there or not. So we know if it is if the QR code is visible, the door is closed. Otherwise, it's open. And you can scan this QR code and find our video on YouTube. Next use case is kitting and packaging process, or statistics for that. And the cost for labor can account up to 65% of total warehouse fulfillment costs. And combined with labor shortage, this results in more companies seeking technological solutions to cost and productivity challenges. So the insight that we want to give in this use case is target time versus actual time for a manual process like packaging, for example, or assembling or something like that. And in this case, we again used our QR code decoder, which can also detect 1D barcodes if the environment is the right. And what you can do here, for example, is that if you have a packaging table, you can use your order slips, which probably already include a barcode or a QR code with an order number. And when you start working at order, you put that slip on the table. You do all the packaging of things, and once you're done with it, you take your slip and put that on the package and hand the package over to the next step. And now with the code, or now with the camera mounted on top of this packaging table, the camera was able to see the barcode or the QR code while you were working on that order, which means that we can visualize the duration per order. So in the top left here, you see a histogram that shows what was the total time of each order in the view. So if you have a lot of bars to the left here, it means that a lot of the orders was very fast to process. And the more bars that goes to the right, the more orders was slower to process. And you can also see in the bottom left the number of different orders detected on the timeline. So there you can see more as a time of day, for example, is there some parts of the day where it's slower to process orders. And you can also get a table of all the different orders and the table that they were detected on, together with the order number. So this again is created with a fixed data agent, getting data from the fixed QR code decoder. And then going more into the developer side of things and compliance side of things, IT operations, looking at the health of the camera. And a functioning camera is more than a piece of hardware. It's a critical component of safety, compliance, and business resilience. Neglecting it can lead to lost evidence, legal penalties, financial loss, and reputational harm. So the insight here we want to give is an answer to the question, can I rely on my cameras when I actually need them? And this is the dashboard that comes built in with that comes bundled with the fixed data agent once you buy it. So you can scan the QR code right here, and you will get to the Git repository with all these dashboards. So the only thing you need to do is to load these dashboards, install the fixed data agent, and then you will have detailed statistics from the cameras. So you can see here that we have 3 different dashboards. We have one dashboard on the system level that is a detailed overview of each individual camera in the system. So here we can, for example, see a timeline of what Access OS version was running in each camera at different times. And we can see when they last reported health data. We can see what is the serial number, what is the product name, what is the external IP and the internal IP, and so forth. And then we have a more system level anomaly dashboard. So the idea with this one is that if you have a lot of cameras, then you don't want to look at all individually. You just want a few visualizations that shows you that these are the bad performing cameras that you might want to look into. This percentage of cameras are healthy, this percentage of cameras are bad, and so forth. And then we have a detailed view for each camera. So if you click on one of the cameras in the system overview, then you get to the detailed dashboard for that specific camera, which you typically would use when you do, for example, a post-mortem of the camera. If something has done wrong, your application crashed, or your camera was unresponsive for a while, then you would look into this dashboard and try to see what metric in the camera was not looking good at this time. And again, just a fixed data agent, all you need to do this. And going even more on the technical side now. So this is more for companies that are operating your own machine learning algorithms, more deep learning applications in the Access cameras. And essentially answering the same kind of questions as before, but more specifically for this application. And reason we want to do this is that AI-based detection systems can only deliver insight if the performance remains stable and trustworthy. When confidence drops, latency increase, detections become inconsistent, problems often go unnoticed until they affect operations. So the goal here is essentially to see issues before our customers see the issues. And the insight is, can I trust my intelligent sensors? So this is an example of a dashboard that we have built for this. You can scan the QR code to the right, and you will get to a detailed blog post with a step-by-step instruction of exactly how we built this dashboard. And what you can see here is a bunch of different metrics, typically called MLOps metrics, machine learning operations, for a deep learning application. So it includes information such as the average latency over the last hour, which is a good KPI for comparing different metrics and or comparing different models and seeing how they evolve over different releases of the application. We can also see the latency over time, which is great to see any spikes, which can affect temporarily during that time span. We can see if any errors have occurred in the application. We can see likelihood for detections and classifications of different objects. So you might have some objects that appear very rarely in the training data set, for example, and then you will probably see that you have very fluctuating confidence scores or likelihood for those objects. So it's a great dashboard for anyone who are operating deep learning models in your Access cameras. And this again was used or was created using the fixed data agent to collect metrics from this deep learning application that we wanted to monitor. And the last thing I want to show is just quick and dirty developer dashboards. So one benefit with the fixed data agent is that it's so easy to create these dashboards that you can use it as a debugging tool. So for example, when we develop our own applications using the fixed data agent, we typically create these dashboards to inspect different debug metrics in the application and see how it is doing. And the why for this is essentially that when you run an application in distributed devices, problems rarely announce themselves clearly. A robust telemetry and debugging framework turns invisible failures into measurable signals, which shortens time to resolution, enables developers to improve reliability, performance, and scalability. So the insight is essentially what is the root cause of my issues, and even to know that there is an issue. So here we have an example of how how a dashboard can look like. So this is a dashboard that we developed for our time and area application when we developed that one. So the time and area application runs directly in the fixed data agent using this Python-like language, Starlock. And we wanted to measure different latency measures to know for sure what latency do we need to expect and where in the pipeline do we have this latency in case we need to optimize something. And doing this was super quick and simple. We just add a single node in the application that collects this information and sends it to the database. And then we create this visualization, quick and easy in Grafana to debug this. So it's a very quick way to keep track of your edge devices. So let's go more on the technical side and take a look at how did we actually implement all of these different dashboards more in detail. So the first thing, starting with the data agent, which is the core of all the dashboards that we have built here. It's easy to use. Our goal was to create something that is as easy and quick as possible to set up, but is still production ready and scalable from the start. So essentially what you need to do is to spin up your dashboard and Grafana stack, load dashboard configurations to get the actual dashboards that you want, and then install the fixed data agent in your cameras. So if we take a look at the diagram to the right, we have the edge agents, the fixed data agent running in each camera that you have connected to your system. We have the database and we have the dashboard. And optionally, you also have these configuration files that you load into the data agent to extend the functionality, extend the work that it does. And the whole backbone for this is open source. So we use Grafana as the visualization tool. It's a very, very common open source project for creating dashboards. We use InfluxDB as a database. It's a time series database, also open source. And finally, we have open source the dashboards that we have created, which you can find in our Git repository by scanning the QR code. And the way to set up this is clone the repository that the QR code leads to, open the folder called System Monitoring, InfluxDB to Flux Grafana, and then run docker compose up -d. And now you have both Grafana and InfluxDB running in your computer with the bundled dashboards already loaded. So the next thing you need to do is just to install the fixed data agent in your camera and configure it to send data to the server that you just have spun up. So do you really need the fixed data agent, or can you do the same things without it? And the short question is no, you don't need a fixed data agent. You can go to the Access developer pages and find an example of creating dashboard using data from Access Object Analytics. So relatively similar to what I showed earlier. But if you start reading this page, you will soon realize that it is actually quite complex to set this up. There's a lot of manual steps you need to do to set up the rule engine camera, MQTT. You need to create an AWS cloud account at Amazon Web Services, and you need to set up a bunch of different resources in this AWS account. And then you need your Grafana instance, which will read data from this. So it turns out that it's quite a complex project, even for a developer to set up. So the answer is probably that no, you don't need it, but you want it. And the first reason for this is that it's much simpler and easier to set up. And also it doesn't depend on Amazon Web Services. So you're not depending on the cloud if you use the fixed data agent with the open source stack that you can run on your own computer. And another really great benefit it gives you is the powerful edge workflows that you can run things directly on the edge device, which you can't do with this access only method of doing it. So one good thing about both the data agent, but actually also about the Axis way of using MQTT and AWS is that you only have outgoing traffic from your devices. So this solves a lot of pain points around having to open ports and firewalls or running VPN servers. That the data agent will run in your device and it will push all the data to your database, which might be located in the cloud or it might be located on a server that you're hosting yourself. So the only outgoing connection you need is the regular TCP, HTTP, or HTTPS ports that you're typically using for all the other computers when you want to access the internet. And the data agent will only send the data that you need. Since you can run these edge workflows on it, you can add filters to make it only send data that actually makes sense to you, which will reduce network traffic, reduce congestion on the network. And one benefit that you get with a fixed data agent is that you get controllable offline buffering. So if we consider our site here on LAN 1, which is suddenly losing connectivity to the database, losing internet access or losing network connectivity to the subnet where the server is located. Instead of losing this data, the fixed data agent will now start buffering up all these metrics that are collected and continue to collect metrics just as usual. And as soon as the connection is regained again, it will send all this historical data and backfill your database so that your dashboards will again show everything exactly what was happening at the site, even when you didn't have connectivity. And this buffering is completely controllable using the fixed data agent. So you can decide yourself how much data you should store and what should happen if it can send it. And as I said, you can filter data directly on the device to only send the data that you need. So the way this works is, for example, if we consider an audit dashboard, let's say that we want to visualize everything that is relating to image and video. So we want to log whenever we are starting a new recording or when our recording is stopped. And we want to log whenever someone is downloading an image snapshot from the camera. All this information is in the system log and the audit log in the camera, but there's a lot of information. There's thousands of other metrics logged to these same log files. So sending all of this from all your cameras to a central dashboard would be a lot of network congestion. So what you can do with the fixed data agent is that you upload a configuration file to each camera that tells the data agent that it should read the information from these two different files. And then you define a grok pattern that will essentially tell it how to parse each line in this file and only match the ones that actually relate to recording events. And then only these matched lines will be sent by the data agent to your InfluxDB database where you can visualize it. And another thing that you can do with the data agent is that you can pull data from any API. So on the previous slide, I showed that the data agent is pushing data to your server, which makes it a lot easier with network configuration since you don't need inbound access to the camera. But some applications are not offering this ability to push the data that you want, but they do offer a fetch-based API to get that information, like an export API, for example. And this was the case when we implemented our occupancy dashboard, that the data that we wanted to get was only available with a pull-based API. And our dashboard doesn't have access to the camera, so we can't pull it directly from the dashboard. So instead, what we do in the data agent then is to create this workflow that tells it that on a defined poll interval, it should make an HTTP request to this other application, which in this case was Access Object Analytics, to get the JSON information. And then we will parse that JSON and we will push that to our InfluxDB server. And this is available in our quick start guide for the data agent, explaining how to do that. And essentially what it looks like is that you have a configuration that looks like this, which tells the data agent that it should use the HTTP plugin to make a request. It tells it which URL to do it to, some different information about parameters to use for the request. And finally, it tells that we should extract a specific field from the JSON and only keep the total number, and that's the only thing that we will send to our dashboard. And in a similar way, you can also extract data from other ACAP applications, but do it more in a push-based way. So if we look at the MLOps dashboard that we showed, where we were running a YOLA v5 application. So the application that we monitored in that case was the Access open source example application for a YOLA v5 model running object detection directly in the Access camera. And that application was already logging all of these different metrics that we were interested in, but it logs them to the system log. So what we did with the data agent there was to create a log parser that is reading these log files, and it is again using grok patterns to filter which lines are actually containing information that we care about, and how should we parse the information in these log lines. So then we end up with structured information in the format that we have defined. And then we push this information and this information only to our database where we can visualize it. So you can see exactly in our blog post by scanning the QR code how we did this. And the reason we decided in this case to go with a log parser, which is not a very optimal or efficient way to do it, was that we didn't want to modify the deep learning application at all. But if we did this in a production scenario, typically what we would do is to modify the deep learning application to send these metrics that we want to log to the data agent. So what we typically do is that we use the socket input in the fixed data agent to create a socket on the device, and then we just write data to that socket. So it's essentially just a file in the file system that you need to open from your application, and you just write the data in a structured format to that. And then the data agent will send that to the dashboard. So the benefit with doing that is that it's much easier to just write the metrics to a file in your application than to implement the whole connection to the database and all this retry, buffering, and so forth. And another thing we also did in this MLOps project in the blog post is that we enrich these messages. So we're not only sending the information that the deep learning application is writing to us, we are also enriching it with a lot of information about the camera, such as what is the serial number of the camera, what is the internal IP address of the camera, what is the external IP address of the camera, for how long has this camera been running, how much available CPU and memory does it have at the moment, and things like this. So it's again about combining these different information from different silos. In this case, it's kind of micro silos in the camera, where information from different subsystems of the camera are interesting to visualize together. And then we can make use of the data agent to merge all these things together and push them to the database. But we can also do calculated values. So in this dashboard, we have one visualization that shows the inference time of the application. And there's 3 different metrics that we are measuring there. We are measuring the pre-processing time, we are measuring the actual model inference time, and we are measuring the post-processing time. And in most cases, what we are interested of is it the total latency, so the sum of these three metrics. But the application didn't produce those metrics. So one way to implement this would be to do it in the dashboard, that we can build into the visualization a calculation that sums up these three metrics. But it's an extremely inefficient way to do it, because every time the dashboard is refreshing, it would need to recalculate the total for all the historical data that you're showing in the dashboard. While the more efficient way would be to calculate it once when you receive the data. And you can actually do that with InfluxDB. You can set up a script that will run every time a new metric is written to the database. And then that script can calculate the total and insert that one together with other metrics. But it's quite complicated to do it. And in this case, it's super simple to do it directly in the fixed data agent, which also have the benefits that it runs the load on each individual camera, so it scales linearly with your cameras. So essentially how you do this is using this Python-like language, Starlark, and you have a function that is called every time a metric propagates through the data agent. And you remember the pre-processing, inference, and parsing latency, the latest measurements. And every time you get one of those, you also send a total latency metric, which is the sum of these three together. So moving into the digital twin, where we have is the door open or is the door closed? What we did here was to use the fixed QR code decoder, which will every frame when it detects a code, it will send that information to the fixed data agent. So it's quite a lot of data. It's something like 20 times per second we get information with the QR codes in the frame. Sending everything to the dashboard would load the network quite a lot and load the server a lot if you have many cameras. So instead we run the fixed data agent, which does the processing and filter out and only sends when there is a change in the door state. So essentially our logic is that if you see the QR code, the door is closed. If you don't see the QR code, the door is open. And then we also add a deadband for to handle occlusions. So if we lose the QR code just for a few seconds, then we don't report anything. But if there has been 5 seconds without seeing the QR code, then we assume that now the door is actually open. And only when there is this state change going from open to closed or from closed to open, then we send a new data point to the database. And for sliding doors, we could even do linear interpolation and give you the openness of the door from 0 to 100%. And as I said before, we have our time in area application, which is analyzing on a track level how long time has a specific object track been visible in the view. And we also have include zones where we filter if you're inside or outside include zones, essentially a polygon. And all of this is done in the fixed data agent as a Starlark workflow. And it's not only time and area that you can do with this, you can do all kinds of different analytics. So you can scan the code and get to a blog post where we show a little bit about it. But essentially what we did here was to have one Python or Starlark filter that looks at the object IDs for the tracks and calculates the total time that a track has spent inside the polygon. And we have a filter for when a track ends, then we can send a notification to the database that now we had a track that was visible for this long time inside this polygon. So it's again consuming a lot of data from the camera and reducing this to a very small amount of data that we actually care about, which is then sent to the database where you can easily visualize it. And essentially the time and area calculation looks like this. So again, it's very Python Python-like code that almost any developer can understand and extend on. So again, I said that data typically spans multiple silos, and in many cases, it's not only data that are produced from the access cameras that you want to visualize in a dashboard, but also a lot of other data. So in one project we did, we were hooking in temperature, humidity readings, and power usage that we got from LoRaWAN based sensors. So essentially, the customer already have these sensors connected to AWS IoT using LoRaWAN gateways. And since our whole stack for doing these kind of visualizations is completely open and completely customizable, it was easy to integrate these external, totally different data into the same dashboards. So we could visualize both information from the access cameras, from the analytics in the access cameras, but also from these other LoRaWAN based sensors, everything in one single dashboard. And the way we did that was essentially to forward messages using the built-in MQTT in the AWS IoT functionality, and using Telegraph on the server, read that into the InfluxDB database. And while this was running, the cameras was of course using the fixed data agent to upload the data from the cameras. So going more into notifications, how we can notify users when something is not looking as it should in the dashboard, when someone needs to spend time actually looking at it. So one integration we have done here was SMS-based notification, to send an SMS with a short information with the data whenever something is off and a link to the dashboard. So the way we did this was to, on the same server that is running Grafana and InfluxDB, we also spin up an N8N container, and then we use the Twilio API. So Twilio is a web-based service for sending SMS messages from an API. And the reason we use N8N in this case was that the customer wanted to have a no-code solution that is easy for them to manage and modify. So the way this looks is essentially that there is a webhook created in N8N, a webhook input. So then Grafana is doing a webhook message to this webhook listener, and then we have some processing logic. We create an SMS text message, or a text for the SMS message, and then we send that to the Twilio API, and we also log the database back to the InfluxDB database, so we can show in the dashboard what was the status of the SMS being sent. But you could also skip N8N, for example, and if you want to, you can even have the Telegraph or the fixed data agent in the camera send the API call directly to Twilio to send the SMS notification without depending on the server with the dashboard. But going back to the N8N solution architecture, one really cool thing you can do here is that you can use the OpenAI ChatGPT models directly from this no-code interface. So you can take this input with the alarm from Grafana, and you can give that to an LLM, which will either create actions based on it, decide is this something important or not, or it can just create a better looking text message, which we will then send in an SMS notification. And you can also do a more advanced solution like we did in our blog post, where we essentially used the OpenAI API directly, and we created a Python agent script that is using this API. And we use a functionality in OpenAI API called function calling API, which means that we can create our own Python functions that gets data from the time series database, consume this data to produce some specific metrics, and then send those metrics to the LLM model. And this means that you can suddenly chat with your database or chat with your dashboards. So you can ask a question. For example, you can connect this to Slack, and then in Slack you can ask a question: are there any of my cameras that are looking worse than others, or was it any camera that didn't behave well at this particular date, and so forth. So if you don't want to just look at the dashboard, you can gain insights instead from chatting. Or if you look at the dashboard, you see something that looks strange, then you can ask the AI agent to explain it in an easy to understand way. But you can also automate this even more. You could run an anomaly detector in the fixed data agent, a very simple anomaly detection model to trigger whenever something goes out of distribution. And then you can use this as a trigger to automatically invoke the LLM agent. Because running the agents are quite expensive, so you can't run them all the time. But if you trigger them whenever something looks strange, and then you have the LLM agent decide, is this something bad that is happening, or is this normal? And then if it is bad, then send a notification either with an SMS or as a Slack message to the operator, who then can go in and look at the dashboard and chat with the AI agent. So this was a lot of technical things on how to create these dashboards. So let me just finish up now with a few slides on how to move forward. If you think this looks cool, I also want to benefit from this technology. What are the next steps? So it depends a little bit on who you are and what you want to do. But one thing you can do is to use this to build your own dashboards. So essentially, the only thing you need to do is to buy a license for the fixed data agent. You buy a lifetime license or a yearly license for each camera that you want to run it in. And then you set up the open source stack on your computer, your server, and AWS instance, wherever you want to host it. And then you start building your own dashboard in Grafana and start writing scripts for the data agent that tells it what information to collect or what algorithms to run in the camera. If you don't want to do it yourself, you can also hire us to implement it for you instead. So this is good for system integrators, managed service providers, solution providers, where you want to be able to add this technology to your portfolio, but you don't want to invest all the time learning how to do it. So then we can build for you, and you are just hosting it and selling it to your customers. And since the data agent is available as a lifetime license, it's great for monetizing because you don't have any running costs. You just buy the data agent once, you run the server your own, and then you can sell it on a subscription or whatever you want to your customers. And if you're an end customer, then it's a bit more complicated. In most cases, we don't work directly with end customers. So the question here is, do you have your own internal system integrator or IT team that is capable of operating the Axis cameras? If the answer is no, then do you already have a system integrator that you're working with for installing your security cameras, for example? If the answer is yes, then do you want to build it in-house, or do you want not to build it in-house? So again, if you want to build it in-house, buy a license for us and start building. If you don't want to build it in-house, hire us to build it for you, and then your internal IT team or integrator can operate it. Or if you don't have an internal, then work together with a system integrator which can maintain it for you. So if you have a system integrator, then we can probably work with them. If you don't have one, then we can recommend one that we can work with. So a few minutes over time, but I hope I still had time to cover all the important and interesting things in this webinar. And as a last giveaway here, we wanted to give you a 50% discount on the data agent as a thanks for watching this webinar. So if you make use of this code, webinar smarter cameras 50, and scan this QR code, then you will be able to buy the data agent for half the price. So with that said, let's see if we have any questions in the Q&A. And I forgot to say that you can write questions by clicking the question mark in the bottom of the screen. And it seems like no one has asked any questions so far. So I'll wait around for another minute or so to see if there are any questions popping in. But otherwise, you can always reach out to us at info@fixit.ai, and we will be happy to answer any questions or show any other demos of what you can do with Fixit data agents and the dashboards. So still no questions. So thank you for watching this webinar, and I hope that it was very useful for you. And if you're not following us on LinkedIn, then start following Fixit at LinkedIn. We have a lot of interesting insights that we are sharing there very regularly. So yeah, thank you for this and have a great day.